Okay, we're going to simplify radicals. So just a reminder, there is another way that we could rewrite radicals as a fraction exponents. So if I have some number raised to an exponent and then have a root attached to that, I can rewrite this as the exponent stays the numerator and the root is the denominator. Okay, so nth root of x to the a equals a divided by n. So just think the root part is the denominator. So since we're simplifying roots, why don't I refresh your memory on some common square roots and cube roots. So the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 64 is 36. My bad, just making sure you're paying attention. Square root of 36 is 6. Square root of 49 is 7. And square root of 64 is 8. Square root of 81 is 9. And square root of 100 is 10. So some common cube roots. Cube root of 1 is 1. Cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. Cube root of 125 is 5. So that might assist us in solving and simplifying some radical problems. So let's start with an example. So how can we simplify a cube root of 0.008? So again, if you have a calculator, it makes it easy. But if you don't have a calculator, we need to think about what number cubed will get us 0.008. Well, cube root of 8 is 2, so a 2 is involved, and if I want to 0.008, that just means I have decimal 2. So 0.2 will give us a cube root of 0.008. Let's look at another example. What if I have the cube root of negative 1,000? Cube root of negative 1,000, again, is asking us the question, what number cubed will get us negative 1,000? And with cubes, we can have negatives, so that will be negative 10 cubed. Again, you cannot take the even root of a negative, but you can take the even root of an odd. So cube root of negative 10, 1,000 is negative 10. So let's look at another one. What if I want to take the cube root of 1 over 27? This means I could take the cube root of the top divided by cube root of the bottom. Cube root of 1 is 1. Cube root of 27 is 3. So 1/3 is my answer. Let's take it up a notch and let's see if we can simplify big square root 16 x to the 8th y to the 4th. So I can split this up as square root 16 times x to the 8th. And remember, a root is the same thing as fraction denominator. So this is a root of 2. So I can take that exponent 8 divided by 2. Y to the 4th. Again, I can take that denominator and divide it by 2. So square root of 16 is 4. 8 divided by 2 is 4. And 4 divided by 2 is 2. square root, again, we want to make sure it keeps positive, but notice that our two exponents, 4 and 2, are positive. So 4x to the 4th y squared will actually always be positive, so we don't need absolute value. So how do we simplify cube root negative 27? A to the 6, y to the 9. So again, we can break it apart. Cube root of negative 27. A to the 6, again, the root is dividing by 3. We have y to the 9th, and again, the root is dividing by 3. So cube root of negative 27 is negative 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. And we're done. Negative 3 times a squared y cubed. Let's try one more. What if we have a 4th root, 16, c to the 4th, d16. So again, I can break this up as the 4th root of 16. C to the 4, again, your root is the denominator, divide by 4. D to the 16, we have root divided by 4. So 4th root of 16, square root, we don't have square root 16 is 4, but 4th root, again, you got to square root that again, would be 2. 4 divided by 4 is 1. And 16 divided by 4 is 4. And here we want to make sure, and we're done, 2c d to the 4th. Okay, so make sure when simplifying radicals, again, if it is a number value, you can directly take the root of the number. Again, if it is has an exponent, again, the root is the denominator. Okay, so let's look at another example. So what if I need to simplify cube root of 27, b cubed y to the 7th. Okay, so we can split this up as taking cube root of the first, 27. Remember that the radical we can rewrite as a fraction. So we can have this divided by 3. Now notice here, 7 will not divide evenly. Okay, so I'm going to rewrite this. Cube root. And y to the 7th, I'm going to rewrite into something that I can divide by 3. Okay, so I can rewrite y to the 7th as y to the 6th y. So let's continue to simplify. Cube root of 27 is 3. 3 divided by 3 is just b. Now, why would I want to rewrite y to the 7th as y to the 6th times y? Well, now I can change y to 6 and divide this by 3. But notice, y to the 1st, I'm not going to be able to evenly divide that by cube root of, I'm not going to be able to easily divide that by 3, so that stays under the cube root. So one last simplification, we have 3, we have b. 6 divided by 3 is 2, and we have cube root y. That's my answer. So one last question, take it up a notch. Cube root of 256 x to the 10th y7. So I'm going to break apart cube root at 256, and again, cube root of 256 is 4. Now, the x and the y, neither one of those can evenly divide by 3, so I'm going to rewrite into an exponent that I can divide by 3. Well, x to the 10th, well, 10 cannot divide by 3, but x to the 9 will, so x9 times x, do we not agree, will get us x to the 10th. So again, it equals the same thing, I'm just rewriting it a little differently. And now let's do the same thing with y to the 7th. Y to the 7th, again, I can't easily divide 7 by 3. So let's change it to y to the 6 times y. Now I can rewrite as a fraction. So this would be x to the 9 divided by 3. I'm the cube root of the second x. Notice I can't divide that, so I'm just going to keep that under the radical. Notice I left a little space because the y to the 6th I can do. Y to the 6th I can divide by 3. And notice the cube root of just y to the 1st. Y to the 1st divided by 3 won't divide evenly, so the y stays under the root. So last simplification, we have a 4. 9 divided by 3 is 3. 6 divided by 3 is 2. And cube root of x times y. Okay, so if you have a root that does not divide evenly, again, rewrite it as the same base, 2 separate ways in order to take at least part of that root out.